This is a demonstration of Farris Engineering's SmartPRV technology, featuring our 2600 series spring-loaded bellows pressure relief valve equipped with a wireless position monitor. SmartPRV technology monitors and reports the pressure relief valve stem position via the facility's wireless network. To conduct our test, we have installed a gateway, which captures the wireless unit's signals. This information is then recorded by a data historian. This demonstration was produced in Farris Engineering's ASME-accepted flow test laboratory located in Brecksville, Ohio. For the following demonstration, we will be viewing the data in real time against the operation of the valve. The valve has reached its set point and rapidly opens or pops to approximately 65% of its fully open or full lift position. This is typical behavior for a direct spring-loaded pressure relief valve set for compressible fluid service. Upstream pressure will now be increased until the valve reaches approximately 100% open. At that point, the upstream pressure will be roughly 110% of the initial set pressure. The valve is now fully open and flowing at rated capacity. Notice how the curve on the lift versus time graph has leveled off and become nearly horizontal. As the upstream pressure is decreased, the valve begins to reclose. When the inlet pressure drops below the reseat pressure, the valve will return to its fully closed position. In our second demonstration, we will show how the SmartPRV can warn plant operators when a pressure relief valve has not fully reclosed and is leaking process media, causing production losses. Again, we see the valve reach its set point and pop open. Upstream pressure is increased until the valve reaches approximately 100% open. At that point, the upstream pressure will be roughly 110% of the initial set pressure. The valve is now fully open and flowing at rated capacity. A pair of locking pliers will now be clamped onto the stem to prevent the valve from reseating. This is done to simulate a valve in-field service that has become obstructed and is unable to return to its fully closed position. As the upstream pressure is decreased, the valve begins to reclose. When the inlet pressure drops below the reseat pressure, the valve will attempt to fully close, but is prevented by the obstruction from reaching that position. Notice the horizontal line at the right side of the graph indicating that the valve remains approximately 25% open. even after the inlet pressure has dropped well below the valve's reseat pressure. This is an indication that the valve has not reclosed as expected after the relief event. This video demonstrates that the Farris SmartPRV, as part of your facility's distributed control system, will accurately indicate when your pressure relief valve opens and closes, and will identify a valve that has not properly reclosed. This will assist you in the safe and efficient operation of your facility and help to mitigate the costs associated with production losses and emission fines.